Hello, my name is Sandeep Gautam and this is my final project submission for this course Software Quality Management at Lund University. In this project, I carried out quality evaluation of open source software projects, Apache Daffodil version 4.2.0. Okay, over the next 15 minutes, I will introduce the project, explain how I carried out the project, mm, and the problem I faced during the project, uh, and share at last I will share my findings and finish with the 10 suggestions that was given in the course for software quality assurance in software engineering. As I chose this project as a solo, I completed all of the work and quality assurance roles myself. Okay, let me start by introducing the project. Apache Daffodil is an open source implementation of data format description language. Usually, it is shortened to DFDL. In simple terms, Daffodil is a translator between rigid, low level data formats and modern easy to easy formats like XML, JSON. This is useful in areas such as defense, telecommunications, and scientific data. And in any field that still relies on binary formats. mm, the project is really mature and active. It is written mainly in Scala with some Java and C. It is organized with several modules such as Core Engine, the Command Interface, and C Code Generator. And it is built and tested with SPT build tool. Okay, I selected Daffodil because it has clear, well-defined job, which makes it quite easy to reason about, and because it has very large existing textures, uh, and that I could evaluate. Okay, let's go with the goal of this project. The goal of the project is to evaluate the quality with software, not to change it. The assignment asks for two separate documents. The first is test plan. We set out the strategy, scope, methods, and tool for testings, and it justify with decisions. The second is test summary report, which presents the result of testing and proposes quality improvement activities. Okay, to share my objectives, therefore, it is that Daffodil does and what it risks carries to define a sensible testing approach for it, to evaluate its existing quality using its own test suite and tools, and finally to recommend ways its quality could be improved. I created the project own test suites as the main expression of how the software is supposed to behave. Mm, I assessed the project against the ISO 25010 software quality models. Okay, I will tell now how I carried out the project. Mm, I followed an for informal but structured process first. I studied project, reading the documentation and source code to understand the Daffodil does, how it organizes modules, and how it is built and tested. Second, I identify the product risks for a data parser. The main risks are incorrect parsing, deviation from the DFTL specification, uh, fail to and it's failed to it fails to reproduce the original data from a parse and on parse round trip. mm, Poor performance or high memory use on large data, weak handling of uh, manifold input and differences across operating system and Java version. Third, I designed the testing approach in the test plan because Daffodil behavior is defined by clear inputs and outputs. I made black box functional testing the primary method using the project test data markup language or TDML. Uh, each test case provides an input and expected info set. The actual output is compared against it. Mm, I complemented with the white box unit test using JUnit and Scala test, and I planned smoke integration, regression, and performance testing as well. Fourth, at last, I evaluate the existing quality. I measure the size of the code base and the number of test cases directly from the source. I explained and examining the test results in the line with the project continuous integration, and I look at the project coverage and static analysis situation. For tooling, I use the project own quality tools because that gives results that match how the project really built and verified. These include SPT as the build and test runner, JUnit and TDML for the test as coverage, and Code COV for coverage, Apache RAT for license checking, and GitHub Action for continuous integration. Mm, okay, now I will tell the test execution and results. Let me know the now present the results, which are the heart of the test summary report. The first thing which stands out uh, is the scale of the test suite measured directly from the version 4.2.0 source. The project contains 8433 parsers, uh, parsers test cases, and 1252 on parser test cases written in TDML. Uh, mm, okay, that is total of more than 16,500 defined test cases supported by around 67,000 lines of test codes, again roughly 118,000 lines of main code. Mm, when I look at the execution outcome, the active test suite parsers, which is consistent with the project continuous integration uh, and main branch being in green passing states of the defined tests. 126 are explicitly disabled in the source using the ignored annotation, so I reported those as script, and no falling tests were found for the evaluator baseline. In percentage terms, about 99 percentage of the tests pass and less than 1% are skipped. Alongside running the test, I look at the code statically using the ideas of the code smells and technical depth that we studied in the course. I sourced the course for the compound technical depth makers and found 160 Toro comments and 26 fix me comments and hack comments at all. Uh, then I rated the project against ISO 25010 quality models. Functional correctness is strong because they were last passing test suit verifies behavior against the DFDL specification. Uh, Performance I rated as adequate since the tool is built for streaming data, but I didn't run a separate benchmark and security. I left as not assessed because it was outside the scope of the evaluation. Uh, the problem I faced during the projects, the biggest challenge, the biggest challenge was size and complexity of the project. With over 100,000 of code across many modules, a heavy Scala and SVT build, it was not practically to build and run the entire project on a modest laptop. I dealt with this by analyzing the source uh, directly to the measurable facts such as test counts and the technical depth markers, and by relying On the project, public continuous integration as the baseline for the pass and fail outcome. The second challenge was unfamiliarity. Daffodil is written in Scala and DFDL standard, and the TDML test format were new to me, so I had to spend time learning the domain because I could evaluate it meaningfully. The third and last challenge was deciding where to focus with more than 16,000 test cases. I couldn't inspect everyone, so I used a risk-based approach and concentrated on the highest critically areas and the modules that I carry the most of the test. Okay, now I will mm, share my findings. The main findings are Apache Daffodil, a high quality project. It is backed by an exceptionally large and well structured test suite. It is continuously built and tested across several platforms and Java versions, and it applies automated style, license, and coverage checks as normal part of this process. I also found areas that could be strengthened. Most of the functional test cases sit in the single large test modules. Some small modules such as C coordinator rely almost entirely on TDML cases. Okay, very less time remaining. I will share what I learned. This project taught me number of things. On the technical side I learned DFDL and Daffodil uh, and how data transformation tool can be tested clearly using input and expected output test cases. I also saw large professional open source project actually manage quality in practice, continuous integration, code coverage, and automated style license get working together. On a process side, I learned the real difference between test plan and test summary report. The plan is written before testing and describe intent, write the while the summary report is written afterwards and describe result improvement. Okay, at last I will say 10 suggestions for quality assurance. First one is build quality in from the start. Apply quality assurance across the whole life cycle rather than relying on test at the end. Second one is automatic tested and run it continuously. Third one is measure code average and set a minimum threshold, paying special attention to error handling and edge case path. Fourth, track technical depth, for example, by monitoring todo and fix me markers and pay it down regularly before it grows. Uh, Sixth one is enforce coding standard and formatting automatically so that style stays consistent. Eighth one is test across all target platforms and environment to make sure that software is portable. Uh, and ninth one is manage defect properly, recording each one, classifying it by severity, and tracking it through to closure. At last, the tenth point is foster a quality culture where the whole team shares responsibility for the quality and uses reviews, inspection, and continuous improvement as daily practice. Uh, okay, at last I will conclude. I evaluate the quality of Apache Daffodil by producing test plan and a test summary report. I grounded it in the real test suits and tools. I found it to be measure high quality projects that passes in active test cases, uh, carries to low technical depth and scores well on the main quality characteristics with a few clear opportunities for improvement. The work gave me practical experience of software quality management and connected ideas from the course to result real project. Mm, and thank you very much for watching. Bye.